Welcome back to another exciting chemistry video. In this video, we are going to learn about looking at measurement and determine the number of significant figures or digit of that particular measurement. Before we start, let's look at the structure of a number. A number is made up of one or more digits. For example, here we have the number 9. That is made up of one digit. But if we have this number, 1.07, this decimal right here, how do you know it's a decimal? It has a decimal right there. It's made up of 3 digits. Now let's look at our measurement and determine the number of significant digits. So what is significant digit? It's basically, it shows the measurement precision. The more precise the instrument, the more expensive it is. So let's look at what does really mean when we're talking about significant digit in a measurement. First thing first, we know that we're using different instruments to measure properties of matter, right? And different measurement will have different precision. The more precise it is, the more expensive the instrument. But if we are scientists and we look at a number, how do we know if something is more significant than other? And the common pattern is that the more decimal place that it has, for example here, this measurement number right here is more precise than that one. So the more decimal place it goes, it is more precise. Now, precision is not the same thing as accuracy, because to measure something accurate is basically comparing to the accepted standard that we have in our textbook. So if you have a precise instrument and you measure wrong, your data will not be accurate at all. Okay, so keep that in mind when we're talking about precision, and it's not the same thing as accuracy. Okay, so let's go back to the ideas of significant digit. All you need to do is memorize 3 important rules. Basically, these 3 situations is the only time when a digit in a number is significant. Notice how we have the name significant figures or digit. We are looking at one digit at a time. So the first thing that we have to look at is that the 3 rules. And if a digit does not follow one of the 3 rules, it does not or will not be significant. Okay, so in this case, the first one is every single non-zero. What are non-zero digit? 1, 2, 3, 4, all the way through 9, except for 0. They are significant. Okay, and in order for a 0 to be a significant, you have to think of this, a sandwich. Okay, it has to be in between 2 non-zero. So the only time a 0 is significant is between 2 non-zero. For example, let's look at this. I have 1, 0, 1, 101. Or I can change this to what? 1 or 702. Notice how this 0 here is between 2 non-zero right there. So it's significant. Or I could have this 7001. These 0 is also significant as well. So that's the rule when non-zero is significant. Now here's the tricky part, or the easiest part. If you have a decimal number, okay, if you have a decimal number, how do you know if some number is a decimal number? Well, it has a decimal. Then you start with the first non-zero, okay, and count all the digits after that first non-zero. For example, right here, is this a decimal number? First thing first, are this 0 significant? No, because they are not between 2 non-zero, so they are not significant. Okay, in this case, we only have 2 sig fig. I'm going to abbreviate as F. Okay, now over here, is this a decimal number? Yes, look at this, that's a decimal right there. We start from our first non-zero, counting all the way to the end. 1, 2, 3, 4. So we have 4 significant digits. Okay, what about this number? Notice how it has a decimal, but again, go back to the idea. We start from our first non-zero. Here we have our first non-zero here, and there's nothing after it, so we just have 1 significant digit. Okay, look at this one, how I changed this and added a bunch of 0 after that. So our first non-zeros right here, and it's a decimal number. We start counting. So 1, 2, 3, 4. So 4 significant digit. There you go. Now there is 1 or 2 exceptions to the 3 rules above, and that is what happens when we do have a number that is not measured. What do I mean by number that are not measured? Well, this measurement is not the only way to get a number. We can actually count. If I were to count 1, 2, 3, 4. I have 4 right there. I'm not really using any instrument, right? In this case, we have something called counting number. And counting number has infinite number of significant. So 5 apples, I have to count one by one. The word infinite means forever true. Think about that part, okay? That means we verify one at a time. The same thing with 100 pennies. If you count one by one, you know it's always going to be true. So that is counting number. Another exception is that when we have a number that's complicated called scientific notation number. For example, let's look at this. What is a scientific notation number? Well, a scientific notation number, in this case, of course, is not the correct format, but it has 2 parts. One is the exponent part, okay? This is the exponent part. And this right here is your coefficient. When we're looking at the measurement of a scientific notation number, we are only looking at the coefficient part. Because this part right here means time to the power of something. So in this case, if this is a decimal number, we go back to our first non-zero, start right there from the first non-zero, count all the way to the end, and we stop there, right? So 1, 2, 3, 4, 5, 6. So we have 6 significant digit or figures. Now let's try this one. We have this right here. We don't care about that part because that's the exponent part. We only care about the coefficient. So start with our first non-zero right here. Count all the way to the end. 1, 2, 3, 4. So we have 4 significant digits. Are you getting really good at this now? So let's do a lot of practice problem because you really need to know how to do this really well in order to understand data. So let's look at this one. Is this a decimal number? No. So we had to go back to the rules. Okay, I'm going to show you a little bit right there. So this 0 are not significant, but this one is right here. So how many significant do we have? Well, this 0 is not significant because it's not between 2 non-zero. So in this case, we have 3 sig fig. Let's try this one. Well, this one's easy. When it's a decimal number, we start with our first non-zero, count all the way to the end. Right there. That's the beauty of looking at number that are decimal. So we have 1, 2, 3, 4, 5. So 5 sig fig right there. How about this one? Well, it is a scientific notation number, so we can ignore that part. We just focus on this one. Now this 0 significant is between 2 non-zero, right? It's between 2 non-zero. Now here this is not. So this is 3 sig fig right there. Let's try some more problem. Now, what about this one? This is a decimal number. We start with our first non-zero, go all the way to the end. 1, 2, 3, 4, 5. So that's 5 sig fig. How about this one? 50 drops. You had to count 1 drop, 2 drop, all the way to 50. So this one is infinite. There you go. Isn't that easy? Right? Let's try this one. Oh, just another scientific number. We ignore this exponent part and we count with this coefficient part. Start with the first non-zero. So we have 3 sig fig. There you go. Isn't that cool? Now we have 11 shots of copper. Again, we had to count 1 shot, 2 shot at a time. So therefore, this is infinite. Okay? How about 500 grams of copper? Well, this 0 are not significant because they are not between 2 non-zero. So they're not between 2 non-zero. So the answer is just 1 sig fig. How about this one here? Mole of Cu, okay, and then this is a scientific number. We have this, the exponent, we don't care, and the first non-zero is right here. So go all the way down, 1, 2, 3, 4. So 4 significant digit or figures. Now let's go to Streamline.com and do some more practice problem that'll give us instant feedback so we can check our understanding right away. And if you have any question, work with your classmate and ask the teacher for support. So in this case, we have this number right here, right? And we have the rules right here. So this is a decimal number. So what do we have? We have for the first non-zero right here, so counting all the way to the end. So 1, 2, 3, 4. So we have 4 significant digits. How about this one? Ooh, look at this one. We have 1, 2, 3, 4 as well because this again is a decimal number. So we don't really care about the 0 rules, okay, to some extent. In this case, 1, 2, 3, 4. So 4 significant digits. This is a scientific notation number. We ignore this part. We go over here, 6.02 times 10 to the third. We don't care about that part. So in this case, it's just 3. And now we can check our answer. And there you go. Let's try another problem. And of course, once you're done, do more problems. We have a lot of practice problems for you, so you can be prepared to know this content really well. Oh, here we have a conceptual question. Okay, let's make this bigger. Significant figures are only applied to what? Well, they are only applied to measurements, okay? Not counting. If a number is not measured, then we can ignore it and assume it has what? Infinite significant figures. Now, blank numbers such as 5 apples, well, right away we know it's counting number. And if we look at the scientific notation number, the only thing we care is the coefficient part. And check our answer. There you go. Yes, that's right. Isn't that easy? See, that is extremely easy once you look at the basic rules and apply. Let's do another one. We have 5.0 milliliter of copper. This is a decimal number, so we start from the first non-zero all the way to the end, so 1, 2. So we have 2 significant. And look at this one, is a decimal number. Our first non-zero is right here, but we don't have any digit after that. So in this case, it's just 1. And here again, we have a scientific notation number. We ignore that part. And here we just have 1, 2, because our first non-zero here. So done. And now let's check our answer. Yes, there you go. So right away, this is extremely easy. Don't get overwhelmed by the number of text that you see in the lecture notes, okay? Take one step at a time and look at the rules one digit at a time, and you are ready to go. And thank you for taking the time to learn this content. And if you have any question, please let us know. And we will see you on another exciting chemistry video next time.